Assalamu alaikum dear students, this is our first video in unit number 6 second year course. This unit is about plane analytic geometry, and in this unit we will discuss straight line in the plane. Now we first come to the definition of a plane. A plane is a flat surface that is two-dimensional, each of whose dimension extends infinitely. Or in other words, a plane is an infinitely large flat surface. Dear students, if we look at this page, we observe that this page is a flat surface. Its first dimension is its length and its second dimension is its width. So it is a flat surface that has two dimensions, and so it can be considered as a finite portion of the plane. Dear students, when a number of pages combine, as in the case of this book, it consists of a large number of pages. If we observe at the dimension of this book, the first dimension of the book is its length, the second dimension of the book is its width, and the third dimension of the book is its height. So this book is three-dimensional shape. Students, you observe that in case of the page, the height of the page can be neglected, but in case of the book, we cannot neglect the third dimension, the height of the book. So we observe that a page is an example of two-dimensional shape and a book is an example of a three-dimensional shape. Dear students, three-dimensional figures are also called solid figures. Now students, we come to the definition of analytic geometry. Dear students, before 1637, algebra and geometry were considered as two different branches of mathematics. In 1637, René Descartes, a French mathematician and philosopher, introduced the concept of coordinate. This concept brings algebra and geometry together. And this new branch of mathematics in which algebra and geometry were brought together is called analytic geometry. In analytic geometry, in certain problems, equations are given and we are asked to find the graphs of those equations. While in certain other problems, graphs are given and we are asked to find the equations for those graphs. Thus, in this new branch, algebra and geometry are studied together, and this branch is nowadays called analytic geometry. The analytic geometry is also called coordinate geometry or Cartesian geometry. Now we come to the definition of analytic geometry. Dear students, on the screen you observe the definition. The branch of maths that combines the techniques of algebra and geometry is called analytic geometry. Analytic geometry is used in physics, engineering, space science, and aviation, etc. Students, you observe that this is coordinate that brought algebra and geometry together, and this concept was given by René Descartes. So René Descartes, which was a French mathematician and philosopher, is credited for the introduction of analytic geometry. As you observe that coordinate is the basic concept that brought together algebra and geometry. So we first come to the definition and the concept of coordinate. Here is the definition of coordinate. Dear students, you know that a line is consisting of infinite number of points. Now if we come to a real line, you observe that a real line is consisting of infinite number of points. We usually associate a number with points in order to locate the position of the point. Dear student, here is a point, we have associated 0 with that. Here is a point, we have associated 1 with that, and here is a point, we have associated -1 with that. In this process, we are associating numbers with the point. Students, a number associated with a point is called the coordinate of that point. So we can say that 0 is the coordinate of this point, 1 is the coordinate of this point, and -1 is the coordinate of this point. But when we come to plane, you know that plane is two-dimensional, so we need two reference lines in order to locate the position of a point. Suppose this is a point P. In the plane, we have two coordinates x and y. The x coordinate is called the abscissa and the y coordinate is called ordinate. What these coordinates denote? Dear student, observe that if we draw a perpendicular from this point on the x-axis, the point of intersection of the perpendicular and the x-axis is x. Similarly, if we draw a perpendicular from the point on y-axis, then this point of intersection of the y-axis and the perpendicular is called the y-coordinate. Students, we observe that this is the x-coordinate. This is the value of x, and it is actually the distance along the x-axis from the origin. And this is y, which denotes actually the distance of the point along the y-axis. In other words, we can also observe that this is the value of y, but this is equal to this one, so we can say that this is y. This is the value of x, but this is equal to that one, so this one is x. Now from this perspective, we observe that actually the value of y is the distance of the point from the x-axis, and the value of x denotes the distance of the point from the y-axis. So these are summarized here. X coordinate is actually the distance of the point along the x-axis, or distance of the point from the y-axis. And similarly, y coordinate is the distance of the point along the y-axis, or distance of the point from the x-axis. Dear students, you must observe that when two coordinates are associated with a point, the point lies in the plane. As in this case, x and y are two coordinates associated with the point A, this point lies in the plane. And if three coordinates are associated with a point, the point lies in the space. As you observe in this case, A is a point having three coordinates x, y, and z, so it lies in the space. Students, our first topic of this chapter is distance formula, which we will use in certain problems. Here we have derived the distance formula for points in the plane. We can generalize this concept in a similar way for points in the space. Now we come to the proof. In the plane, the distance between the points A and B is given by this formula. Now we come to the proof of this formula. Dear students, as A and B are 2 points having 2 coordinates, so these points lies in the plane. Suppose this is point A and this is point B. You already have the concept of the coordinate and selection of x1, y1, x2, y2, as it was observed here. Now what is x1? We draw a perpendicular from the point on the x-axis. This point of intersection is called x1. And similarly, if we draw a perpendicular from the point on the y-axis, this point of intersection is called y1. In a similar way, if we draw a perpendicular from point B on the x-axis, this point is called x2. And if we draw a perpendicular from this point B on the y-axis, this is called y2. Now first we come to towards the difference between x1 and x2. Dear students, from x1 to x2, the distance covered is actually the increment in x, the change in x, and that change we denote by delta x. When the point was here, its x coordinate was x1, and when the point moves to B, the x coordinate moves from x1 to x2. Similarly, when point is at A, its y coordinate is y1. When the point moves from A to B, the y coordinate moves from y1 to y2. So here the x coordinate moves from x1 to x2. There is a change in x, and that change in x is delta x. And the y coordinate moves from y1 to y2, so here is a change in y, and that change in y is denoted by delta y. You know that the change is always calculated from final minus initial. So this is initial, this is final. Delta x is equal to final minus initial. This is initial, this is final, so delta y is equal to final minus initial. Now dear students, to find the distance between A and B, which is AB modulus, first we construct a well-known figure of the trigonometry, which we call the triangle. First we have to pose a horizontal from this point A. This is the horizontal line passing through point A, and we draw a perpendicular from point B. The point of intersection of the horizontal line and the perpendicular is C. Thus we have a right angle triangle A, B, and C. Here is a right angle at point C. Dear students, you know that right angle triangle is a triangle that obeys Pythagoras law. So here we can obey Pythagoras. We can apply Pythagoras law because it is a right angle triangle. Now we come to the proof. From the figure we observe that ABCD is a right angle triangle, so we are obeying Pythagoras law. The law says that the square of hypotenuse is equal to the square of base plus the square of a perpendicular. You observe from here that actually hypotenuse of the triangle is the distance between A and B. So hypotenuse is equal to AB distance. This is the base AC, which is actually the difference between x1 and x2, delta x. So base is equal to delta x. This is perpendicular BC, which is equal to the change in y. So perpendicular is equal to change in y, delta y. We have observed that H is equal to AB modulus. Similarly, base is equal to delta x and perpendicular is equal to delta y. Now we have delta x is equal to x2 minus x1 and delta y is equal to y2 minus y1. Now to eliminate this square, we have to take square root. Now taking square root on both sides, we have AB modulus is equal to this one, and this is the proof of the formula given here. Dear student, you have observed that here only positive sign is used, but usually when there is a radical sign with variable, we are associating plus minus both signs. You know that here the formula denotes the distance between A and B, and you know that distance is always measured in positive, so we have ignored the negative sign. Dear students, the reduced course for the upcoming exam, the examples from this exercise are 6.1 and 2, 6.1 and 4. Similarly, the questions from the exercise for the upcoming board papers are question 2, 3, 5, 6, 7, 9, part A and B of 10, part A and B of 11, and part A and C of 12. This is the end of the first video. Please remember the distance formula, which we will use in our questions in the second video. Goodbye. Allah Hafiz.